So as we previously said, the periodic table is broken into periods, and a period is a column inside of the periodic table. And that is how the periodic table is arranged, is to put specific elements in the same column because they tend to have similar properties. And what we want to do is go through and we'll find out certain columns or periods have specific names, and to take a second and talk about some of their general properties. And here, periodic tables are broken into two different types. I like using the old school numbering system. They have a new one that I really don't like. And the idea is column 1 is 1, and it just counts all the way across to column 18. So it makes it a lot easier to identify. Some more modern periodic tables may have this, crazy new system, which I don't understand why they did it. But this is the one that I use. So group 1 is the one all the way to the left, and they are called alkali metals. And you want to take a second, and even though they put hydrogen right here, hydrogen really isn't considered a metal. It is actually considered to be a non-metal, so we kind of put it over here sometimes. But it has similar properties. It tends to form a +1 charge, so they kind of put it over here too. But it's technically not a metal, which will be important later on. But the rest of these, lithium, sodium, potassium, are called alkali metals. And they tend to be very soft, low melting point solids. So I have played around with sodium, and it is actually maybe a little bit firmer than silly putty, but you can actually squish it and pull it and break it, and it's very soft. Alkali metals tend to form cations of a +1 charge, and so remember, because it's part of the main group, that's easily predictable. So if I say what's the charge on something from a group 1, it's going to be +1. That's what we expect it to be. So alkali metals, the reactivity is kind of the same, just to mention it, but if I react to alkali metals with water, and you've probably seen this on YouTube, when you throw sodium or lithium into a bunch of water, it tends to have a very violent reaction. So what it does is it tends to form hydrogen gas, and that's part of the reason why it burns so well. And it forms an OH, a hydroxide. So where M is one of the group 1 metals, if I throw sodium metal into water, it ends up forming sodium hydroxide. If I throw potassium into water, it forms potassium hydroxide. Also, alkali metals tend to react with the group 17 elements, which are called halogens, which we'll get to in a minute, and they tend to form salts. So things like sodium chloride, table salt, and potassium fluoride. So group 2 is right next to that. They're called alkaline earth metals. And alkaline, remember, it means basic, and that comes from the idea that when we react these elements with water, they tend to form a basic compound because they form a hydroxide. So all of these form a +2 charge, so this is given. So things like magnesium, if I say it's in an ionic compound, you can predict that it's going to have a +2 charge. These also react with water to form hydrogen gas and a hydroxide compound. Transition metals, they mostly form cations. It's pretty safe to assume that they form cations, but there's always exceptions to the rule. But the idea here is, we mentioned this, they may form a positive charge, but a lot of them have variability. So some of them have very defined charges, other ones do not. And that's why we call it a transition metal. It's not part of the main group, which means that if we want to find the charge on iron inside of an ionic compound, we need more information. We'll actually talk about that. So transition metals are a little bit harder, so they tend to contain the structural metals, things that we build things out of, like titanium and iron, and they tend to be made up of coinage metals, so like copper, nickel, silver, and gold. And a lot of these are essential to living organisms. So this is part of, when you take supplements, part of what you're getting in there is iron and zinc are necessary for living organisms. So group 13 through 18, that's in the upper right-hand corner of the periodic table. These are metals and nonmetals. This is where we get into organic chemistry. So literally, organic chemistry, you spend a whole year talking about the bonding ability of the element carbon, and then in there, nitrogen, oxygen, and some of these other ones like phosphorus or sulfur are also very important parts of organic molecules. So in there, group 5 elements, so that's the column with nitrogen, they tend to form -3 charges. Group 6 is when we are going to have the oxygen and the sulfur at the top of the column, so those tend to form -2 charges. Halogens are group 17, so they're just to the left of the noble gases. Halogens tend to form anions, so a -1 charge. So fluorine, chlorine, and bromine have a very predictable charge of -1. Halogens tend to exist as diatomic molecules. So if we want to find the elemental form, so when you play around with a metal like iron, you can actually have an iron element, but if you have a halogen in an elemental form, they form diatomic molecules, so like Fe2, Cl2, and Br2. So noble gases are always all the way to the right, and noble gases are, they're important, but we don't spend a lot of time talking about them because they are unreactive, and it's very hard for them to form bonds with other elements. And the exception with this is xenon, and we'll talk about that later. Almost all noble gases are an individual monoatomic gas. So when we have like argon, it's individual argon element kind of floating around in the gaseous form. So when we look at this, the atoms that we have that with predictable charges, so our group 1, group 2, the very top of group 15, group 16 are oxygen and our sulfur, group 17 are halogens. And one of the metals that are over here, aluminum, has a very predictable charge. And 3 of our transition metals, in particular zinc and silver, zinc only forms a +2 charge, silver only forms a +1 charge. So they actually have a predictable charge. Even though they're part of the transition metals, they're one of the few that have a very predictable charge. And this is going to come up later on when we actually name inorganic compounds, that we're going to name these 3 elements a little bit different than we do other transition metals. So we'll see that in a bit.